Hello. Today we're going to learn about trig. Yay! A wire supports a tree. The wire is staked into the ground 10 feet from the tree, and it forms an angle of 70 degrees with the tree. We will be able to find out how high up that wire is in the tree by using trigonometry. So that's what this whole lesson is about. We can't solve the problem right now. We'll be able to solve it later. But for now, that's what we have to look forward to. Trigonometric ratio. What is a trigonometric ratio? It is a ratio of the length of two sides in a right triangle. Now, there are three different ratios that we're going to learn. We are going to learn the tangent ratio, the sine ratio, and the cosine ratio. And each of the three, we will have, I have written A next to them. That A represents an angle. So whatever the angle measure is, or whatever the angle is that we're talking about, that's what A represents, okay? So the tangent ratio, tan A is equal to the length of the leg opposite angle A over the length of the leg adjacent to angle A. And we will know that as the shorthand opposite over adjacent. So just remember, tan represents opposite sides over the adjacent sides. Looking at example 1. Tan S and tan R are what I'm looking for. So I have tan S. That is equal to the side opposite angle S over the side adjacent to angle S. And let me make a comment about this adjacent. Adjacent is never ever the hypotenuse. Okay? It is never ever the hypotenuse. So when I say adjacent, don't ever say hypotenuse for that. When I want you to call out the hypotenuse, I'll say hypotenuse. What is opposite of this angle S here? Well, there's 77 degrees, angle S. Opposite is 80. And the side that is adjacent to S is 18. I can simplify that and say that is the same thing as 40 over 9, and just keep it as that. That is it simplified. Now you might say, well, what in the heck does that mean? Well, it is the tan ratio from that angle with respect to that angle. But suppose I didn't know the angle measure. I would be able to use this tan ratio and say, hey, the inverse tan of, what's that ratio? 40 over 9 is equal to, and get your handy dandy calculator out. I just happen to have my Mac Daddy one. And I would find the, oops, my B. I need to first, let me go home. Settings, let me make sure, and I want to make sure you know to set your settings. You can see mine are in radians here. There's my radian. I need to set to degrees. So with your calculators at home, please set your calculator to degree. I'm going to make that my default. And we will not be working with radians. You can save that fun stuff for pre-cal. So my calculator, where was I? Tan, I want the inverse tan of 40 divided by 9. And when I hit enter, it'll be 77-ish degrees, and it is 77.3. 77.3 degrees, which is that guy right there. So it's just a little bit more accurate than that 77 that you see. That is what this whole ratio business means. I also want to find tan R. And actually, you know what? Let's save tan R for class. Woohoo. Let's do this one in class. This way we get a little feel for it in class too. Guided practice. Find tan J and tan K. Tan J, that's this guy right here. And you know what? Let's save this one for in class. I want to do some with you, and I just want you to kind of, because this video is going to be too long if I do all those. These two I will do. Example 2, find leg lengths. I have this angle known to me, and I am looking for the opposite, and I know the adjacent. Well, anytime I have information on opposite and adjacent, I know that I'm interested in tangent, because tangent, in this case it's 37 degrees, is equal to opposite over adjacent. Right, guys? Opposite over adjacent. Another thing I want you to know is that this right here is one number. Tan 37 is one number. Tan is not separate from 37. They belong together. I want to solve for x. When I solve for x, I'll multiply each side by 18. So multiply by 18, multiply by 18. Sounds like familiar algebra, right? Because it is. I want to know what 18 tan 37 is. And I will put in my calculator 18 tan 37, enter. And that length is 13.564. Let's write that down. 13.564, and that is the length of my x. All together. Got it? 13.564. I didn't say to round to the nearest tenth, so we'll just leave it as that. The next one. This one's done a little bit. It's the same problem, but not really, and you'll see in a minute here. I have an angle measure, I know the opposite, and I'm looking for the adjacent. Sounds like a recipe for tangent, doesn't it? Tangent represents opposite and adjacent, so it's tangent of 32, and that is equal to opposite over adjacent. Can you see how this problem is a little different? Look at where the x is placed. And look at where the x was placed in the problem before. Before it was in the numerator, now it's in the denominator. Well, that just means we're going to have one extra step, is all. I'll multiply each side by x, just like I would if it were an algebra class. And the x's on the right go away. And on the left, I'm left with x tan 32, and that is equal to 11. Well, now I still don't have x all by itself. I need to get x by itself. Remember, this is being multiplied. So, and tan 32, or tangent 32, is one number. So what we do to one side, we do to the other, and we will divide each side by tan 32. And we have x is equal to, with your calculator, 11 divided by tangent 32, and that is equal to 17.6037. 17.6037. That is my x length. And there you have it. We will do example 3 in class and the other 2 in class. Let's look at sine and cosine. Sine and cosine ratios are ratios of the lengths of a leg and the hypotenuse, which is why we're doing these two together, in a right triangle. And let's look at sine ratio first. I have, remember, that A right there is an angle. And it's sin, which you're going to be tempted to say sin. Please say sine. It's not sin, it's sine. And that represents the length of the leg opposite of angle A divided by the length of the hypotenuse of angle A. It's only one hypotenuse, but that is, we'll know that to be the opposite over hypotenuse. Now remember, tangent was opposite over adjacent. Remember I said the adjacent is never the hypotenuse? I'll always tell you the hypotenuse when I want you to use the hypotenuse. So here we are, we're finding the sine ratios. Sine S. Sine S is equal to, here's my S, look like a familiar triangle, opposite, starting like the tangent. But remember, sine represents opposite over hypotenuse. And the hypotenuse is 82. And that reduces to 40 over 41. And just like I could use, and oh, actually I will, show you that I can use this ratio by putting in the inverse sine of 40 over 41. Watch. So very cool. Inverse sine, and it was 40 divided by, what was it, 40, 41? 41. Enter. Look, it's 77.31 something something 96, which is ish. This is ish. 77.3. Oh, doesn't that look familiar to what we had with tangent? Don't you love it? We will do sine R in class. We will do example 2 right now. Looking at this, I have this angle that is 48 degrees. I am given the side opposite, and I'm looking for the hypotenuse. Sounds like a recipe for sine. And we will take the sine of 48 is equal to opposite over hypotenuse. And we will multiply each side by x. Say goodbye to the x's on the right. And we are left with x sine 48 is equal to 12. Remember, it's multiplication between the x and the sine 48. In an effort to get x all by itself, I must divide each side by sine 48. Sine 48 is one number. And we have x is equal to, ish, 12 divided by sine 48. And that is 16.1. So that is 16.1. I think I wrote the longer number before. We'll just leave it in tenths. 16.1. And let's look at the next one. The next one is, I have this angle measure. I'm looking for the opposite, and I know the hypotenuse this time. So here we have it. It is sine 25 is equal to opposite over hypotenuse. To get x by itself, I must multiply each side by 19. Say goodbye to the 19s on the right, and we're left with 19 sine 25 is equal to x. We'll plug that in your calculator, and you have 19. Trig is sine 25 degrees equals 8 point, let's just say approximately 8-ish. So it's about 8. Cool, right? I know you're feeling it at home. Cosine ratio. The cosine ratio, remember what's A? It is the angle. So whatever angle we're talking about. Cosine A is the length of the leg of the adjacent angle A over the hypotenuse. So this one's going to be adjacent over hypotenuse. This is the third one I'm giving you. Notice how all three have had different criteria. Tangent was opposite over adjacent. Sine was opposite over hypotenuse. Now I have adjacent over hypotenuse. So let's look at cosine of S. The cosine of S, here we are. Same triangle once again. Just kidding. Here we are, 77. Cosine, it is the adjacent, so adjacent is 18 over the hypotenuse. Hypotenuse is 82. And when I simplify that, I have 9 over 41. And just like I did with the other two, I'll show you how that ratio can really mean some good business when it comes to the angle measure. So if I look at the inverse of cosine, what was it? 9 over 41. So inverse cosine, 9 divided by 41, and it's 77 degrees. Shocker. 77.3 degrees. Don't you love it? Look at that. We used 3 different trig functions and got that same number. Looking at these two, and then we'll be cadiddly done, and we'll do the rest in class. So I have an angle. I'm looking for the adjacent, and I know the hypotenuse. Sounds like a recipe for cosine. Cosine of 75 degrees is equal to adjacent over hypotenuse. And if we multiply each side by 20, say goodbye to the 20s on the right, and we are left with this chunk-ish. 20 times cosine, was it 75 degrees? I hope. 5.2. 75, yes. 5.2. Yay. That is the length of x. Let's real quickly do this next one. I am afraid to look at the time. Cosine 62 is equal to, hey, adjacent over hypotenuse. Sounds like cosine. Multiply each side by x. Say goodbye to the x's on the right. And we are left with cosine, or excuse me, x cosine 62 is equal to 12. Oh, say, we're looking for x to be by itself. So, divide each side by cosine 62. Say goodbye to those cosines. And we have an answer-ish. And it is 12 cosine 62. It's 25.6. 25.6-ish. That is your x, and the rest is for tomorrow. See ya. I'm afraid to look at the time.